going to try to be able to predict charges and then also name ionic compounds. Okay, so you have this list. Is anyone missing this polyatomic ion list from last time? Is there a few of us got it? You got it?
Yep.
Okay. Yes, I have tape. Well, everyone has this list? I handed this out last time. I can't remember.
You did? Do you have any more?
I do. I think I have 2 more.
You don't have to know.
You do have to memorize that. Or
You
put it
can
on
just
your
put it on your
notebook.
notebook.
So this will not be, you will not get this on the test. So you either have to memorize it or put it on your notebook.
I'll do that.
Okay, so good. We either have to memorize this or put it on a note card. All right. We copied this down before, right? Or the alkali and alkaline earth metals, they both have a set charge. So this is called a common charge. This column always forms +1 charge. This column always forms +2. And then the non-metals over here, this column, nitrogen and phosphorus are always going to be 3-. Oxygen's column will always be 2-. And then fluorine's column will always be 1-. The noble gases will always be a 0 charge. They don't like to form ions, okay? And then there's a few in here that are exceptions that we need to remember. So silver always forms +1. Cadmium always forms +2. Zinc always forms +2. And then aluminum and gallium always form +3. Okay? Everything in blue that's not highlighted either doesn't form an ion generally, or the things over here, the transition metals, form multiple charges. So we can't say for sure iron is always going to be iron 3. No. Iron can be iron 2, iron can be iron 3. Vanadium can be like 3, 4, 5, 6. So the transition metals, they don't have a common charge. These are the only elements that have a set charge. Every time you see them in an ionic compound, they'll be this charge.
We will see them on Alex then, right?
Yes, you will see them on Alex.
Even the ones that are specific?
Yes, you will see silver on Alex, and I think I've seen zinc on Alex.
Okay, but they have rules then.
Yes. Silver is always +1. Zinc and cadmium are always +2. Aluminum is always +3. Gallium is always +3. Does that help?
Sure, yeah.
Okay. So we need to remember these charges. So the columns are pretty easy. +1, +2, +3, -3, -2, -1, 0. So that's, if you remember those trends. And then we just have a few exceptions. Silver, cadmium, zinc. Okay. All right, we care about this because we're going to use that to name for and figure out the charges. Okay, we've got this. Most of the transition metals and post-transition metals and lanthanides and actinides have more than 1 charge. So these are our exceptions again. Again, aluminum is 3+, zinc is 2+, silver is always +1, cadmium is always 2+. Okay, those are our exceptions. So if they show up, you should know they always form the same charge. Okay. Questions on that? Yeah. There was the gallium also. I don't know if I've seen that one go up on Alex, but I can put it.
Like strong close, because there's no air. That makes a great sound.
see a few pencils writing still. I'll give you a minute. Okay, so go ahead and I'll give you just a few seconds. What are the common charges for these ions? If they formed an ion, what would their charge be?
Let's do the krypton is 0. Oxygen is
E is
-2.
E is negative.
Silver is 1. Silver is 1.
Silver's 1.
Bromine.
Silver's 1, yeah, -1.
-1. And then negative
Is it?
1.
Oh, yeah. Oxygen's -2. Ag is. Silver's 1. Oh, I was thinking aluminum. Aluminum.
I just stand by
Oxygen is 1.
Oxygen is
2.
All right, let's come back up here. So, are there any that you have questions on? You figured them all out? Okay, I think the tricky ones are the exceptions. So how about this one? What's the charge always on? Good. On silver, it's plus. How about oxygen? Good. And remember, if we're writing the charge, we write the number and then the minus. If it's 1, we only have to put the charge. Okay. Any other ones that are tricky? How about
aluminum?
Okay. Good. 3 plus. Good. Okay. Are we okay there? You can figure that out. These ones are okay. What's phosphorus? What's phosphorus?
I don't remember. It's 3 negative.
Good. 3 minus. Good. Okay. All right. So that little number above on the right hand side, that's called our oxidation number or oxidation state. It's just a superscript next to the number. Okay, that's just what we call it. It's called the oxidation number or oxidation state. Yeah, Phil.
So oxidation occurs when oxygen gives electrons to like metals, or does it occur when the electrons are taken away from the metals?
Yes. So oxidation is basically how many electrons you have. So oxidation state. Oxidation is when you pull electrons out. You lose electrons. Yep, so this is how I remember. Oxidation is loss, reduction is gain, and that spells oil rig. That's how I remember. We will talk about that in, I can't remember, chapter 6. Okay. All right, so we talked about our transition metals. They have more interesting charges, so we can change the charge. This is interesting for like if in your car battery, lead can go from 4 to 2, and that's how we can move electrons. So transition metals, because they have more than one charge, they are more indecent. Okay, so that's, if you have a transition metal, we are not going to remember all of their charges. Okay, we're going to use something else to figure out what charge we have. Okay. All right. So this is how we're going to figure out if we have an ionic compound. We need to figure out the charges for both ions that are participating in that ionic compound. So first, we're going to figure out each ion. So we're going to look, does it have a common charge? Then if it's a common charge, then obviously it will be the common charge. If it doesn't have a common charge, like our transition metals aren't always the same charge, they don't have a set charge, or our post-transition metals, they're not always set, then we need to figure out what charge it can be, okay? And then we're going to see, is the ion positive or negative? And then we need to charge balance those two different atoms. So if we go through an example, this will make more sense. So is the ion positive or negative? This is talking about, we talked about ionic bonds last time. So ionic bond has what type of elements? Generally. Good, metal and non-metal, good. So if we have a metal, is it going to be an anion or a cation? Good, the metal loses electrons, it's going to be a cation. So what does that have to be if it's a non-metal? Is it going to be, it's going to be the anion, good, good. So that's what we're talking about, is that an anion or a cation. The metal will be a cation, the ion will be the non-metal. Yes?
Why is that?
That has to do with the octet rule. Do you remember talking about that?
Is that like
Okay.
when they like lose or gain electrons?
So that they have 8 electrons, yes. So if they're over really close, so I just look at the periodic table, like we're always trying to get to be a noble gas. So those nonmetals are really close to being a noble gas. All I have to do is gain a few electrons. Thanks. And then the other ones over there, they're too far to gain electrons, so they're just going to go backwards and be like the noble gas before them. That's how I think about it. Okay, so this is Morgan and Phil. You can go anytime during the period. So will you go after notes? Will you go after notes? Thanks. Okay. All right. We're okay here. Where's my cursor? There it is. Okay, so go ahead and see if you can figure out the charges for the metal and the non-metal, or if it has a polyatomic ion. Go ahead and see if you can figure out the charges.
Also, negative.
Are you okay over here?
Yeah, it's been easier.
Did that just happen?
Yeah, that was.
Oh,
Sorry, I was like.
No.
Yeah, this is, sodium over by hydrogen.
Yeah, so I.
Stockton,
Okay.
Na is over by hydrogen.
Oh, we're doing this. AL. Your charges. Oh.
Wait, is it based on?
That would be.
So that would be.
Is it, are you thinking based on ions or columns?
What's up? You okay?
I think we're talking about valence electrons, but like we're talking about ionic charge. So yeah, the ionic charge is what we were just. I'm also a little confused. I thought,
But you could be right also.
I thought Na would have like a plus one valence electron.
It would be what,
Or wait,
what are the charges
like a
on
plus
the
one ion. A one plus ion.
I don't think that we're gonna do it.
It is.
Krypton would be zero.
A one plus ion.
would be neutral. And then, let's say
And then a
chlorine,
2 minus,
that
it
would
would
be
have a
plus
1 minus charge.
or 3 plus.
No.
Sorry, same negative. Or 1 negative, sorry. And then oxygen would be 2 negative, and then nitrogen
Oh,
would
yeah,
be
there's
3 negative.
So it's perfect.
All right, how are we doing?
It
We're doing okay?
That's gonna be -4.
And it was
Because -4 is
One
-2 plus 2.
Oxygen would be minus 2, so that would
Yeah,
be
it's too much math.
what?
I just think
Yes, we can move on.
Wait, no, actually, no. I have an example.
Yeah.
Sorry, can we move on?
Okay, let's do a few of these. Oops. I don't know, I just went this out. Okay, is there one up here you want to do?
The first one.
The first one. Okay, so we've got Na. Oh, why is it doing this?
It wants to move on too.
It wants to move on too. And now my button is under my other button. Okay,
You just went back.
one more. There we go. Okay, so this one, do either of those have a common charge?
No.
No.
Yes.
Yes.
Yeah.
So what charge does sodium usually form? It's the common charge for it. Good. Na is always going to be plus. How about oxygen? Good. Oh, I just wrote. We'll just go like that. -2. Okay, so the ions that are participating in sodium oxide is sodium plus and oxygen 2 minus.
Was that it?
So that would be, that would know all
That's-
we can do there.
Yep, we're just looking for the ions.
Oh, okay, that makes
What
sense.
ions are participating?
That makes sense, it confuses us with the ending.
The third one? Okay. This one?
How I
Okay.
there's two things there.
So do either of these have a common charge?
I don't know how, I don't know what's actually, it makes sense in my brain.
So this one is a polyatomic ion. So its charge, phosphate is 3 minus, and there's 2 of them.
Copper is 0, plus anything, right?
Copper, it's in an ionic compound, so it's going to be charged.
Okay, but what would it be charged?
That's what we're figuring out right now.
Oh,
So
okay.
we look at this one. This one's common.
Okay.
This one's a phosphate. This is a polyatomic ion from our sheet.
It's a minus. This is negative.
Okay. Phosphate is 3 minus, right?
Yeah.
But there's 2 of them.
So it's a positive.
So together, these 2 are 6 minus.
Oh.
Yeah.
There's no positive. A negative.
And over here, our formula has to add to 0. So we have 3 coppers. So we have to do 3 times something plus 6 plus -6 is going to give us 0. So what does the copper have to be charged?
2.
Positive 2, good. So 2 plus. If we have 3 coppers that are 2 plus, that'll give us a +6 charge. And then 2 phosphorus that are 3 minus gives us a minus charge, so that gives us a 0 charge. Phil.
So if the formula doesn't have like an element that has a common charge, we're trying to zero out something.
Yes.
Okay.
Good. If it doesn't have, so copper doesn't have a common charge. It can be 2 plus, it can be 3 plus, it could probably be 4 plus. So we have to zero out to figure out that charge. Yes. Other questions?
But then if it has like 2 elements with common charges, it can be like any number at the end, or does it also have to be 0?
It should zero out.
Okay. All these should 0 out.
It should zero out. These should all zero out, unless I made a bad example. Okay, do you want to do another one? Yeah.
Yes.
Okay, which one should we do? Any of them. Yep. KMNO4. So, do we recognize any polyatomic ions here?
Yes. It's
Okay.
Permanganate.
Good. This is permanganate. Permanganate. So this is manganese. This is permanganate. That has to do with the oxygens. Per is talking about oxygens. Okay. So what's the charge? So we know we have two pieces. We have potassium, and we have this polyatomic ion permanganate, 1 minus.
Yeah.
Okay. Oops.
Because it's what it says on the paper.
So permanganate's the last one. MnO4 minus. So these atoms have a minus charge. So how about this one? Does it have a common charge?
Plus.
It's plus. So we can find this by either charge balancing, or if you look on the periodic table, potassium K is in the first column. So it's plus.
And so that's just the answer?
The answer for the first one?
Yeah.
It would be
This
Na plus
one?
and then O or oxygen.
So it's just
to
the whole
negative.
thing, you don't like combine.
Okay, so but then on like
This is
Alex,
Telling the formula. Yes.
I'm confused. On Alex is kind of weird because like it'll have like aluminum 4, carbon 3, and then like you have to figure out the charges. But then for some reason it's like aluminum 3 minus or something, and then
So you're just trying to find.
copper
the-
4 plus or something. It's like really confusing.
Aluminum should always be plus 3.
Oh, okay.
Because aluminum's common charge is 3 plus.
And then
So
carbon
Alex-
is 4 minus or
Yes.
4 plus. It's just really weird because I had to like do it on Alex and it just like.
Okay,
makes sense.
if you pull it up during some work time, we can look at it. Sebastian.
Alex, would it just be, would it do like copper and stuff like that? or-
Yes, yes. You will have to figure out some charges.
Okay.
Okay, other questions? Should we do this one? Let's do this one.
Yeah.
Okay, do we see anything that has a common charge? The set charge every time? Oxygen, good. So it's probably gonna be the non-metal that has that. Okay, so what's our common charge for oxygen? 2 minus, okay, and then this is mercury. Is mercury one of our exceptions? Do we know the charge? Okay, so we don't know the charge. Is it gonna be positive or negative? Good, why?
Instead of 0 out.
Good, it has to zero out. We have a minus, so this must be a plus. And it's also metal. Metals form cations. All right. So, but we have 2 mercuries. So what does the charge on the mercury have to be? We have 2 of them. So this is, overall, this is a 2 plus charge, but we have 2 mercuries.
1 plus.
So it just needs to be 1 plus. So Hg in this compound needs to be plus to balance. If I have 2 mercury plus charges, that will balance with oxygen 2 minus. That'll add up to
So-
0.
Oh, now I think I
We're just
got it.
adding up to 0.
So, mercury, if it has like 2 on it, or like,
Yep.
let's say Na2,
And
then it
A2, that means
yeah,
they have to balance.
they have to.
Yep. Yep. Okay. We're doing all right? Okay. Okay. And you will practice this on Alex too. So if you come across that, you can ask too. All right. So this is, we're talking about the formula unit. In an ionic compound, we don't write out each atom. Okay. If I had a grain of salt, that would have like millions of sodium atoms and millions of chlorine atoms. So instead of writing sodium, millions of them, chloride, millions of them, we're going to list the smallest ratio of atoms. So for sodium chloride, it's 1 to 1. For zinc oxide, instead of writing 2 zincs to 2 oxygens, we divide off and we use the simplest ratio of the elements to each other. Okay, that's for ionic compounds. This is different than covalent compounds. If we have a covalent compound, if we change the number of carbons, that changes the molecule, it changes the properties. But if we lose a sodium and a chloride in a salt crystal, it still has the same properties. Okay. All right, the other thing that you need to watch out for, and I'll repeat this next time, but if we are writing the formula, we don't write the charge in the formula. Okay, we could figure out here, oxygen has a 2 minus charge, zinc has a 2 plus charge. We can figure that out from the formula. We don't write that in the formula. So don't write the charge in the formula. Only write the charge if it's asking you what the charge is. Okay, questions here? This is just kind of housekeeping to make sure we know what we're talking about. Okay, here we go. I keep losing my icon. Okay, all right, so now we need to know how to name these things. If we were naming ions, we need to name the cation part and the anion part. The cation part is really easy because it keeps the same name. So if we start with sodium metal, this is sodium metal. If we change it to a cation, it looks like this, we just call it sodium. Okay, so sodium metal, now it's a cation, we still call it sodium. Okay, calcium metal, if it's now it's a cation, we still call it calcium. So that's easy. You just figure out what its name is on the periodic table and you call it that. Okay, so not too hard. For cations. So like sodium chloride, the first part sodium, we're talking about a cation, but we just call it sodium. So the cation just keeps its same name as the neutral atom. All right, for anions, this one's the trickier part. We change the ending of the atom name to "ide." So if we have oxygen, now we have oxygen 2-, we're going to call that an oxide, the oxide anion. If we have a chlorine atom, and then it gets one more electron, we're going to call that the chloride anion. Okay. So anytime it's a non-metal and it's gaining electrons, we're going to add "ide" to the end. And I think this shouldn't be too different than what we've heard before. I think we're familiar with ides, like carbide, oxide, chloride, fluoride. So hopefully this isn't too weird. But that's why we're doing that, because it's an anion. This is just our rule for naming. Questions, we're all right? Okay, here are some examples. I would not memorize these. These are just some examples. So bromine becomes bromide, chlorine becomes chloride, iodine becomes iodide, nitrogen becomes nitride. Yes?
Would we just, could this go on like any chemical on the periodic table? Or,
As long as it's an anion.
oh,
As long as it's forming an anion.
okay, got it.
And so generally, metals are going to form cations.
Okay.
So I can't think of one like right off that's like cobaltite. That's like, I haven't ever heard of a metal where we change the name to ide. Just the
Okay.
non-metals, just if it's an anion.
Okay, got
Does
it.
that help?
Yep,
Okay.
that helps.
Okay. All right. Go ahead and try to name these compounds. If you put sodium and chlorine together, we get sodium chloride. Okay. Go ahead and try these ones.
Sodium. Aluminum chloride. I don't know how nitrogen works. I think it's like, I want to say it's sodium nitride. Maybe it might be.
Oh, it might be
Nitrate, I think 8 is something else. I think actually.
Sodium nitrate? Yeah, we can do this.
And then so many
Yeah.
calcium. Yeah, plus two.
Yeah.
Okay, I heard some people talking about nitrate. Nitrate has oxygens in it. This one is, so this would be sodium nitride. Good. So that's something that sometimes people will switch with phosphate. Phosphate has oxygens. This has no oxygen. So just be careful. Phosphate is different than phosphide. Okay, phosphate is on here, nitrate is on here. When we're talking about nitride or phosphide, we're talking about something without oxygens. Does that make sense? Okay, watch out for that. That tricks some people last year. Okay. All right. When we are naming compounds that could have a different charge, so all the transition metals except our 3 exceptions, the post-transition metals besides gallium and aluminum, and the lanthanides and actinides, they can have different charges. So we need to specify what charge we're talking about. So if we're looking here, we have 3 chlorines. Each of them has a minus charge. So overall, this has a 3 minus charge. So what is iron here? Good, it has to be a 3 plus. 3 plus to cancel out these 3 minus chlorine charges, okay? So in the name, I have to specify. This is iron 3 chloride. This is iron 2 chloride. I'm telling you the charge because otherwise you won't be able to figure that out. Okay, iron chloride. This iron chloride has a different color than this iron chloride. This iron chloride has different properties than this iron chloride. So I have to tell you what iron charge the compound has. So I do that by putting the Roman numerals in the center. So iron 3 chloride, this one is iron 2 chloride. Okay, questions on that? That's because iron can have multiple charges. So anytime we are looking at an element that could have different charges, we have to do that. But silver, we don't have to do that because silver is always +1. Strontium, we don't have to do that because strontium is always 2 plus. So it's only when it's a metal that could have multiple charges. And I've written, this is one of the most missed questions on the test last year, the chapter 3 test last year. So when you write this in Alex, you just use a capital I. So shift I. Do you guys know how to write 5 if you needed a 5 charge? V, good, capital V. What about 4? 1V. Oh, so it's going to be I. IV, good. Yep, good.
I'm confused.
Okay, what part?
Everything.
Okay, did you see how we found the charge for iron? Okay, so we're looking at this chlorine. What's the charge on chlorine?
Sorry. -1.
Good. So chlorine has a -1 charge. There are 3 of them. So there's a 3 minus charge.
Okay.
And so then I need to make sure that this is equal to, the charge is equal to 0 for the overall compound.
Yeah.
So then iron has to be, if I have a 3 minus on chlorine, what does iron have to be?
3 minus.
That'll make it 6 minus.
Sorry, 3 plus, right?
Yeah, good. 3 plus.
Okay.
So 3 plus 3 minus gives us 0.
0.
Okay, and so that's where this number is coming from.
Oh, okay.
So it's the 3, the charge on the iron.
Right.
And then this one is iron 2 plus for the same reason.
Yeah.
This one was 3 plus.
Yes.
And then
Okay.
I'm specifying that it's.
Okay, so it just has to equal 0 every time.
Yep. The metal plus the non-metal, all their charges have to cancel to 0.
Okay, got it. Now I understand it.
Okay, good. Okay, other questions, thoughts? If you have a question, probably other people have a question. Okay. All right. We've done this. Okay, we'll just walk through this, but we've talked about this. So first you're going to figure out the charge of the cation from the anion, and then you're going to name the cation using its metal name. Then you change the non-metal, the anion name to the ide. Oh, if it's a transition metal, if it has multiple charges, then you have to say the Roman numeral. If it's not a transition metal, if we have a set charge every time, then you don't put the Roman numeral in. Okay? You write the cation first and the anion second. So metal goes first, anion goes second. So we're just memorizing the process. We're just getting familiar with the process to name. Okay, questions on that? Does that make sense? Okay. Okay. All right, so go ahead and practice naming these. These all have transition metals.
Oh, I already got the second one. That's pretty easy. Maybe. I already got like what how to find it.
Copper 1 sulfide.
Oh, okay. Copper 1 sulfide. Oh, wait, no, yes, that makes sense, yes. Yeah, okay,
Yep.
Does the third one have to be copper 2?
What?
I don't know.
oh,
Does
wait,
it have
copper
to be
2.
or no? Is it copper 4?
Oh, okay,
Three copper
okay.
more than one charge,
The
or is
third
it
one,
one of our set
Third
charge?
one would be copper 2, right?
So it has to be copper 2.
Number 3?
Yep.
Got alright, and then.
What's PB again?
So it's gonna be
46. So it's just gonna be,
Okay.
neon-2 chloride.
Okay. Makes sense?
Chloride.
Where's that?
Yes.
It's in the 11th.
Okay, sorry, I thought you said.
It's in the 14th column.
Okay, let's go through some of these. Are there any that you want to go over? If we don't go over all of them, which one do you want to go over? The second one? This one? Okay, so we need to figure out the charge. Is copper, can it have more than one charge?
Yes.
Yes. What about sulfur? Okay, so what's the charge? Good. Please work. Okay. So we have a 2 minus here, and then we have 2. This is going to be some kind of plus charge. We have 2 something charges, plus 2 minus gives us 0. So what does that have to be? Positive, just positive 1, right?
Yeah.
So if I have 2 positive 1 charges, that will balance this 2 minus charge. Okay, so then what are we going to call this? Copper, because this is just copper. And then what's the charge? 1. The charge is 1. This is the charge. This is not the number of things. We're looking at the charge. Copper 1. What is it? 5. Good. Copper 1 sulfide. Okay, makes sense? Yes. Do you want to do the next one? Or a different one? This one? Okay. So we need to figure out the charge. We decided copper can be different charges, so we need to figure out the charge. So what's the charge on Cl? Okay, 1 minus. But there's 2 of them, so overall this chunk has a 2 minus charge. So what does copper have to be to cancel out the 2 minus charge? 2 plus, good. Okay, so what would this be called? Good, copper, and then II chloride, good. Okay, be careful with spelling. Chloride has that weird H in there, so just, that does matter. Make sure you spell it right. Yes?
Why does chloride keep its name?
So chlorine is actually chlorine,
Oh.
and then
so
we're
it's
just
chloride.
switching the end.
Stop it.
Okay.
I got it.
So you're on it. You're like, I already changed it in my head.
Yeah.
You got it. Okay, excellent. Okay, how about the next? Do you want to do the next one or the last one? Let's do one more. Last one. Okay, what's this called?
Is it?
What? Lead. This one's lead. Good. We've got Br. So what's the charge on Br? Good. And there's 4 of them. So what does lead have to be? Good. Okay, what's our name then? Lead. Good. So we just start with the metal. Lead, charge, IV, and then bromide. Good. Bromide. Okay. Questions on that?
I got it now.
Okay. So if it can be multiple charges, you have to specify the charge on the metal. If it's always the same charge every time, then you don't have to specify. So like silver or potassium. Okay. Polyatomic ion, you just find the metal, find the element, and then name it. Okay, so should we try that? Okay, what would these ones be?
Ready for the aim. Calcium 1.
So be careful here. Some of them you need to write the Roman numeral, some of them don't. So be careful, watch that.
Oh no. Okay.
Calcium and CIO. So calcium chloride.
Okay, so
Calcium chloride.
So remember, these are all polyatomic ions, so kind of on your sheet.
Oh yeah. Chloride. Chloride.
So
Is that I?
calcium 1.
How do you
right?
learn?
Yeah.
You don't-
Okay, what's the first one?
Chloride ion? That's it?
Calcium,
Yeah.
and then what's that be?
Well, no, I
This is
mean,
the chloride.
oh, I thought they were combined.
So it's just calcium chloride.
That's it.
This is the
Calcium,
chloride
right?
ion. Okay.
Oh, it's just calcium chloride?
Yeah, look, because on this, it says, you're not skill.
Oh, good stuff.
Yep. Yeah.
So,
Okay, so it's just aluminum?
Yes. And you don't have to put the N. This is the
Aluminum
N.
carbonate.
So you don't have to put N unless it's in the formula.
So
Iron.
you would have to have the
Iron.
phosphorus.
Yes. So
Sodium
That's
hydroxide.
Yep.
Aluminium.
Aluminum.
Yes.
Silver.
Yes.
Okay.
Yeah, perfect.
Got that.
That's good. Okay, let's go over a few of these. What would this one be? What's our name? What's the name for this one?
Carbonate.
Good. Okay. But let's start with the middle. So it's gonna be
Aluminum carbonate.
good. Aluminum. Okay. Do we need the Roman numeral here?
No,
Why not?
that's a special rule.
Good. It's a special rule. Aluminum is always 3 plus. Okay. So we don't have to specify. If I say aluminum, I know automatically that's 3 plus. Okay. That's why I don't have to write that. Just let's write
This
it.
is the last one.
All right. Other ones you want to do up here?
Wait,
Yes.
so how do you know when you don't have to write the Roman?
You have to remember.
So all the ones that don't have exceptions.
All the ones that aren't exceptions on that first graph, the blue, this one back here, this graph, oops, wrong way. Where is it? Here. Anything in blue you have to write the Roman numeral.
Oh, anything in blue we have to?
Yep, anything in the boxes you don't write the Roman numeral. So these you don't, these you don't.
Oh, okay.
Everything else could be multiple charges.
Okay.
So you have to specify. These ones, that column is always +1, don't write Roman numerals. This one's always +2, don't write the Roman numeral. Always +1, always 2+, always 3+. Don't write the Roman numeral. Does that help? I'm not sure. Okay, the best way to do this is to practice. Okay, so practice in the Alex. And you can ask me too. Okay, let's go back to this one.
So for the iron one,
Yes.
you have to write the Roman numeral.
Yes, why?
It's in the blue section.
Yes, it's in a blue section. Iron can be 2+, 3+, 4+.
It would just be iron,
You know,
two.
you know phosphorus has like this, just
Phosphorus? Yes, will.
Will?
Yes. But this is not phosphorus. Oh, okay, you're asking for Alex.
Yeah, I am.
Okay, oh, why is this not working? It says it's on. Okay, now it's on. Iron, what?
Is that one?
2, good. We have the charge of 2, and what's that ion?
Phosphate.
Good, phosphate. Okay, be careful. If it's in a compound, we don't have to put ion. Okay, so these are all labeled as some kind of ion. That's because we're talking specifically, this is the phosphate anion. But if it's in a compound, then it's just iron 2 phosphate. Okay, we're talking about the compound. Questions on that? Do you want to do one more?
Yeah.
Okay, how about this one? The last one.
Silver nitrate.
Good. Silver, nitrate.
Silver
Do we have to specify the charge? No, because silver is one of those metals that always forms +1. So we don't have to put the Roman numeral. Okay, are you okay there? Okay. All right, we have a few minutes for work time. So now I would work on the lab. If you haven't turned the lab in, please turn the lab in. Last day to turn it in is Thursday. So make sure you do that. Then work on Alex chapter 3 or the pre-lab for lab 3.
Turn it in.
No, I think I'm good.